Black holes, the cosmic monsters that swallow everything in their path: light, matter, even the very fabric of spacetime. For decades, scientists believed nothing could ever escape them. But now, the James Webb Space Telescope may have just changed everything. What it saw coming out of a black hole has stunned astrophysicists and may rewrite the laws of physics as we know them. Launched in December 2021, the James Webb Space Telescope has been humanity's most powerful eye in the sky. Capable of peering deep into the infrared spectrum, it allows us to see not just across unimaginable distances, but back in time to the earliest days of the universe. And among its most recent observations was a target that had always fascinated astronomers: a supermassive black hole in a galaxy over 800 million light-years away. This wasn't just any black hole, it was an active galactic nucleus, one of the brightest and most energetic objects in the universe, powered by a black hole millions of times more massive than our Sun. The black hole itself was, of course, invisible, but its surroundings, the swirling accretion disk of superheated gas and dust, blazed brightly in Webb's infrared view. This was nothing unexpected. What was unexpected was the strange anomaly detected in the frames. A narrow, focused stream of material seemed to be emerging from the black hole's event horizon, the ultimate point of no return. This was something astrophysicists had only theorized but never directly seen. For decades, black holes were thought to be perfect traps. Once something crossed the event horizon, it was gone forever. Of course, scientists are familiar with relativistic jets, powerful streams of matter ejected from the poles of black holes, created outside the event horizon as magnetic fields hurl material away at nearly the speed of light. But what Webb saw wasn't coming from the polar regions. This stream was coming from near the equator of the black hole, apparently inside the area where no light should escape. And yet, Webb recorded it. The discovery sparked immediate debate in the scientific community. Was it an imaging artifact? A trick of the telescope's instruments? The James Webb team triple-checked the data, compared it to Chandra X-ray Observatory and ALMA in Chile, and the phenomenon was still there. It looked as if the black hole wasn't just taking in matter, but somehow ejecting something else entirely. Hawking radiation in action. Stephen Hawking famously proposed that black holes can emit radiation due to quantum effects at the event horizon. But Hawking radiation was predicted to be incredibly faint, far too weak to detect from such a distance. Yet Webb's infrared sensors seemed to capture a structured, directional release of energy, not just random radiation. Wormhole exit. Some theoretical physicists suggest black holes could be connected to white holes, hypothetical cosmic objects that expel matter instead of consuming it. Could this have been an exit point for matter that fell into another black hole somewhere else in the universe? Quantum tunneling event. In quantum mechanics, particles can sometimes tunnel through barriers thought to be impenetrable. Could particles at the edge of the black hole's singularity have somehow tunneled through the event horizon? The strangest part wasn't just what was coming out, it was what it looked like. Webb's spectrum analysis showed that the ejected material wasn't ordinary plasma. It contained highly exotic particles, ones that shouldn't naturally occur under normal conditions. Some matched the predicted signatures of Axion's hypothetical particles that could be a major component of dark matter. If that's true, then Webb may have just accidentally observed dark matter being released from a black hole. Yet despite its immense influence, dark matter has never been directly observed. Scientists have only inferred its presence from the way it bends light, holds galaxies together, and shapes the large-scale structure of the universe. To see even the hint of its particles emerging from a black hole would be revolutionary. If the James Webb Space Telescope has indeed captured this phenomenon, then it could provide the first tangible evidence of dark matter's true nature. It would also suggest that black holes are not just cosmic traps but perhaps gateways of transformation, capable of converting ordinary matter into exotic forms or releasing particles from the quantum fabric of spacetime itself. The laws of relativity, which described the gravity of massive objects, and quantum mechanics, which governs the smallest particles, were already uneasy partners. A discovery like this could force scientists to finally reconcile them into a true theory of quantum gravity, something Einstein himself dreamed of but never achieved. For now, researchers are cautious. Webb's data is being examined alongside results from ground-based observatories, particle detectors, and upcoming missions designed to hunt dark matter directly. Yet one thing is clear: whatever was seen near that distant supermassive black hole is not easily explained by known science. For decades, the event horizon was thought to be the ultimate one-way boundary. Now, if material or even information can leak out, then the black hole information paradox takes on a whole new dimension. Stephen Hawking argued that information falling into a black hole could be lost forever, violating the rules of quantum mechanics. Others suggested it must somehow be preserved, hidden, or encoded in strange ways. If Webb's detection is confirmed, it may mean that information doesn't just survive, it escapes. That could transform our understanding of entropy, time, and the very arrow of causality. Imagine a black hole not as a cosmic eraser, but as a cosmic archivist, releasing fragments of what it once consumed. The philosophical weight of such an idea is enormous. Black holes could become the universe's storytellers, whispering back the secrets of stars, planets, and civilizations long devoured. In that sense, Webb's image is not just a scientific milestone, it is a reminder of how little we know about the universe we inhabit. Meanwhile, the global scientific community watches with cautious excitement. Teams from CERN, NASA, ESA, and universities worldwide are racing to model the event, running simulations of black hole physics under exotic conditions. New instruments such as the Square Kilometre Array in radio astronomy and next-generation gravitational wave detectors may soon provide additional evidence. And if they do, humanity may face the dawn of a new era, the ability to study dark matter directly, not just indirectly. That would finally to some of the deepest cosmic mysteries. For now, the James Webb Space Telescope hangs silently at L2, a million miles from Earth, staring into the abyss. It cannot tell us what it means. It can only show us the evidence. The interpretation, the leap of understanding must come from us. Some theorists whisper about the holographic principle, the idea that our three-dimensional universe is projected from information encoded on a distant boundary. If black holes truly leak information, then they may be the proof of this cosmic hologram, windows through which the deeper architecture of existence is glimpsed. Others suggest something even stranger. What if black holes are not endpoints at all, but bridges, gateways that recycle matter and energy into newborn universes? Each jet of exotic particles could be the embryonic spark of another cosmos, branching off into a multiverse beyond our reach. In that view, Webb's discovery is not just about one galaxy, but about the birth pangs of infinity itself. And then comes the most haunting speculation of all. If matter and information can emerge, what of life? Could black holes preserve the fundamental codes of biology, consciousness, or even civilization swallowed long ago? To entertain such an idea is to step into science fiction, but history has shown that today's fiction often becomes tomorrow's science.